They're like,
yeah, it's fine. So, real quick, some factoring stuff. What I did, very few people had taken test 7, but the people that had, I combed through the data and just tried to ascertain what was the stuff that was the most problematic. I don't know how valid this is because, again, it wasn't like there were a ton of people that had taken it, but it seemed from what I saw like the binomial factoring patterns, for whatever reason, were the ones that people struggled with the most. So let's hit those first. So what would we do here if we're going to factor, we're supposed to factor this expression down here, v to the 4th minus 81.
Find the square root of negative 81 and put like it.
Of 81 you mean, right?
Yeah.
Wow. Okay, what is the square root of 81? 9, okay. So which pattern would we use here? The one involving squareds or cubes?
Squares.
Squares, yeah. Okay, so we could just go ahead, let's get rid of this guy. Don't even need that one. And let's use this pattern. What is, by the way, the pattern for difference of squares? A squared minus b squared.
A squared minus 2ab.
Okay, hold on now. Are you sure you're thinking about now? It's really easy to confuse. There are different kinds of patterns we're dealing with here, right? In fact, let me pull up.
excuse me?
Oh.
Right, so here's all the different patterns that you guys are going to want to put on flashcards. Now notice there's a difference, right? You've got these product patterns. Expansion means multiplying out, right? You got these product patterns, a plus b quantity squared and a minus b quantity squared. Those are different from the factoring patterns. See the difference? This is when we've got the whole quantity being squared of a plus b or a minus b, and these are just shortcuts for multiplying it out. These are the factoring patterns. There is no factoring pattern for a squared plus b squared, right? But for a squared minus b squared, that's the one that factors into the product of those two small factors, right? It's easy to confuse those, but be careful about that, right? That's one place where people on the test made some mistakes, even just at the start on the easy memorization stuff, is they mix those up, but they're very different. Okay, so back to business here. So what is that pattern again, that factoring pattern?
A plus b.
A minus b,
A
times a plus b. There you go, good. So
is that a typo?
what's that?
Ain't a typo. Oh, no, it's a minus, not
B plus A?
a.
Oh,
minus
it's
a.
Oh, yeah, it is. You're right.
Wow.
Good catch. Thank you. You're on the ball.
I'm on top of things today.
You are, man.
You're on the ball.
There we go. Let's fix it. Okay, so in order for us to use this one, though, we might need to make a substitution because that doesn't look like something squared. What could I substitute, though? Like maybe call it like y or something to make it look like something squared instead.
Y equals B squared.
V squared. There you go. So v to the 4th is the same thing as v squared, right? So this would just become like y squared then. Minus, and we already know 81 is 9 squared. Okay, so then we're just following the pattern where the a in our pattern is replaced by y and the b is replaced by 9, right? So what does this factor into?
Y minus
Y
9.
minus 9 times Y plus 9.
There you go.
Yeah, I was trying to say that, but you.
Okay, are we done? Oh, we're not. We have to go back to v's, don't we? Right, so we're not done. First thing is we got to go back to v's. So this becomes,
And we can go even farther.
okay.
Should
Okay, what can we do now?
v minus 3 squared
Wow, Blake.
times v
I'm
minus
proud of you.
plus 3 squared.
Okay, 9 we could replace with 3 squared. Very good,
V squared you can replace just v.
right? And then v squared plus 9, can we go further with that? No, we can't because of the plus sign, right? When there's a plus sign there, there is no sum of squares pattern.
B squared plus
So
9.
even though it looks like v squared plus 3 squared, that we don't do anything with that.
Wrong.
Sum of squares stops. We can't factor it. But this one we can.
Wow.
So this guy, the last one, the v squared plus 9 is done. But what could I do with this one?
V minus 2 times B, or sorry, 3, so B minus 3 times B minus 3 times B squared plus 9.
Times, what would it be? B
Or
minus
plus
3
3.
times B plus 3. There you go. Okay, give me thumbs. That all make sense? And then we would be done, right? We could not break those apart any further. Okay? Good? All right, so what about one like this, solving an equation?
Yes.
So this involves a little factoring, but also the steps for solving a polynomial equation. What do we always do first?
GCF.
Make it equal to 0. Before we do anything, we got to put everything on one side and set it equal to 0. So we're going to we're going to subtract that 36y term over to the other side, and that's going to give us y cubed minus 36y equals 0. Okay, step 1, put it in standard form, equal to 0. What's the next part of the process for solving a polynomial equation?
GCF.
Okay, we got, and that's a small part of a larger issue, which is we got to factor everything, right? We got to factor the polynomial. Everything on the left side now has to get factored. First step is GCF. Okay, what is our GCF here? Yeah, we can undistribute a y, and that leaves behind what? There you go, right? That leaves behind y squared minus 36, and all that stuff is equal to 0, okay? So far, so good. Are we done factoring?
No.
No, we go a little further. The blue factor, it looks like what pattern?
2 squares. The A squared minus B squared.
There you go. So 36 is the same as 6 squared. Good. So we get, don't forget, we've still got that y out front, but the difference of squares splits the other one up into what? And y plus 6. Good.
Unknown caller.
Oops. Ooh. No, I don't think I have to take that one.
I'll tell you.
There is, I could be getting an important call. I have to step out and take. Sorry if it happens. So what's the next part of this? We got it all factored. Step 1, we put it in standard form. Step 2, we factored the polynomial. Last step is what property? We apply what property? What do we call that one? Real important. Zero product property, right? Think what the zero product property does. And don't just get in the pattern here of just like, like thinking about this like just some steps you're memorizing that you're just going to forget. Think about the theory or the reasoning behind this, right? Once we get this whole thing factored, the way that we're going to find all the values of y that are solutions to this equation is by applying the zero product property. The whole point of factoring this thing is so now we've got small little pieces that are easy to deal with, and because their product is 0, that allows us to find the values of y that are going to work. What's the only way that these 3 factors could multiply to 0? Say it again.
If one of them is equal to
If one of them is equal to 0, right? So we just have to look at what are the values of the variable y that would make each one of those individually 0, because that's how we get a product of zeros when we multiply by 0, right? So by the zero product property then, what's the value of y that makes that first factor 0? 0, yeah. Okay, what's the value of y that would make the second factor 0? And the third one? There you go, right? No big deal, we got this. Okay, let's see. Last one. Let's do one more of these. Okay, is that right? Let's see, is that a good place to stop? Yeah, that's a good place to stop for today. Okay. So what's the pattern, if we're gonna factor this, what's the pattern we would use here? Because it's a binomial, so we have to use a pattern, right?
Or A cubed plus B cubed.
A cubed plus B cubed. Is there a GCF? Because we want to try to do that first.
No.
No GCF. Okay, good. So we're going to use A cubed plus B cubed. Now, what is that pattern? How do we factor a sum of cubes?
A plus B quantity,
A plus B, I heard, okay.
quantity A squared plus 2.
What's the next sign gonna be?
Minus.
Minus, remember, it's always, we go same, opposite, plus.
AB plus.
AB plus B squared, right? Okay, good. And so then our job is just to figure out, well, what are we replacing the A and the B with? The A is what is replacing whatever we're cubing to get the first term. The B is what we're cubing to get the second term. B is easy. What do I cube to get 125? 5, yep. Okay, A is a little tougher. What do I cube to get 64 times x cubed? 4x. There you go. Okay, so 4x is like my A. And my B is 5, right? And I'm just going to follow my pattern. Okay, so what's that giving me? Well, then I get A, which is 4x, plus B, which is 5. Okay, now this one's a little bit trickier. What am I squaring here for A? I'm squaring the whole thing. Okay, I got a question. Thumbs up or down. Can I distribute that exponent to the 4 and the x? Yeah, I can. How come? Because they're multiplied. Right. When can I not? Add it or subtract it. Okay, good. So then this one becomes, if I square both of those, what do I get?
16x squared.
Aha, 16x squared minus AB. What's that going to be? Yeah, 4x times 5 is 20x. And then, here, let me get rid of that's kind of, oops. I gotta get rid of that line. It's kind of messing us up there. We don't need that. And then finally, plus, what's B squared going to be? 5 squared though, right? So 25. Okay, everybody good? Okay. It's factored. Now, should I try to factor that trinomial? No, right? Remember, when we use these patterns, the quadratic part that we get, the big factor, is never factorable. It's an irreducible quadratic. So it can never go further. Okay, good? Make sense? Okay. Tell you what, let's do one more. Then we'll, just so we get one more out of the way, and then we'll be good. So how about this? Now this is a word problem. We did I think we did like a different one last time. Let's look at this one. One positive number exceeds another by 3. What does that mean?
X plus 3.
Okay,
X
so,
plus 3.
okay, good. So then we know we've got two numbers, and it's probably a good thing to write that down. If I want to figure out, like, how am I representing these two numbers? The first number equals X. The second number equals what then?
X plus 3.
Okay, good. And it tells us that their product is 88. So what does that mean?
Equals 88.
Say it again.
Equals 88.
What equals 88?
X plus 3. X. First plus the second.
First plus the second? Hey, you guys, tune in over here, guys. All right. If it's their product, what does that mean?
Oh, they're multiple.
Multiplying. Okay, good. So that's telling us X times X plus 3 equals 88, right? Okay. So now I've got an equation. I can forget about words for a while. I can flip into math mode and just solve that thing. Okay, so what do I do to solve? Okay, I distribute, right? First thing is distribute. So I get X squared plus 3X equals 88. What's next?
Or do we just subtract it in?
Okay, good. I got to get it in standard form. So I'm going to subtract the 88 to the other side. Hey, I need you guys to not be talking back there, please.
Quit farting and we can focus.
I understand there's an issue, but let's get past it. So how about this? What do we do next then? We've got this thing in standard form. What do we always do? What do I have to do to that polynomial now? Got to factor it, right? I've got to break it into pieces so I can use the zero product property. Right now, who knows? How are we going to know what value of X is going to miraculously make all those terms add to 0? That's too tough. But if we break it into a product of small factors, zero product property makes this simple, right? Okay, so we're factoring a trinomial. What would my magic numbers have to do here?
Add to 3 and multiply to 88.
Okay, good. They're gonna add to 3 and multiply to
88. Negative 88.
negative 88. So what are the signs gonna be if they multiply to a negative and add to a positive? Negative and positive, which one's bigger?
Negative.
Positive,
What?
because they add to 3,
Oh.
right? So the positive one must have been bigger if they add to a positive. What are the numbers? 11 and 8.
Wow, Cody, you're on top of things.
Okay, so then what are my solutions here? By the zero product property. Negative 11.
But when you put it in, it's usually 11.
Dude.
Okay, yeah, let's talk about that. So mathematically, we have 2 solutions, right? Okay, but let's go back and read the problem. The problem is very specific. It says positive number exceeds another by 3. Okay, so they're positive numbers, right?
So it has to be 11.
So, yeah, so then because it has to be positive, we're gonna cross that one off. That is not part of our solution. Sometimes on this one, people put both the 8 and the negative 11. That's not right. We only want the positive one. Mathematically, negative 11 is a solution for x, but not for us because we only want positive ones. So we're keeping x equals 8, right? So if we keep x equals 8, what are we gonna do with that? Well, we're gonna go back now and plug that in up here, right? So if I plug in 8, what's that give us?
11.
And then how about if I plug it in there? 8 plus 3 is 11. So those are my 2 numbers, 8 and 11. Positive 11 though, right? Not negative 11.
It's always going to be something like that. So it's like when we're doing it, do we need to like put it back in, or can we just, is it usually going to be the negative turns into?
Well, usually, but not always. Yeah, you gotta check. You just gotta plug it back in. Okay, make sense?
Yes.
We good? All right, so then I'm gonna leave this up here for you guys. Again, I've got flashcards. How many people have made flashcards? Okay, how many people feel like they maybe ought to make some flashcards?
Yes.
There you go. Have at it.
Pay 50 cents to make you some flashcards.
How many